Welcome to today's explainer. We use numbers every single day, right? We totally take our basic understanding of them for granted. But how do we actually build that foundational comprehension from absolute scratch? Well, today we're unpacking the clever hidden structure behind a primary math chapter that is specifically designed to teach learners how to count to 100. It's honestly a brilliant masterclass in pedagogy, and we're going to look at exactly how it guides the learner step by step, literally from concrete objects all the way to abstract mathematical grids. Let's get right into it.
Okay, so we start off in this world, and notice how it doesn't kick off with a boring, intimidating list of digits. Instead, we get this vibrant, playful scene that immediately sets a really fun exploratory tone. We've got a whimsical giraffe, birds flying up in the sky, little animals interacting. Think about what this actually does for a learner. Instead of framing math as this rigid chore, it turns the whole journey into an adventure. It's basically telling the reader, hey, numbers exist in a living, dynamic world. This is our starting line. It creates a welcoming environment before the heavy cognitive lifting begins. It essentially tricks the brain into relaxing, which, as we know, is the absolute perfect state for absorbing new information.
All right, so how do we start building that foundation? We do it by grouping by tens.
To truly grasp the massive scale of 100, the source material first grounds the learner in the physical world using one foundational rule, the power of 10. This brilliantly illustrates the whole concept of grouping. Look at the character here, Simran. She's packing oranges, and it visually shows how individual ones are physically bounded together into a 10. The text asks the learner to just observe Simran putting these oranges into boxes, noting that each box holds exactly 10. This isn't just a random counting exercise, okay? It is a very deliberate physical representation of base 10 mathematics. By grouping the oranges like this, the learner stops seeing 20 loose, chaotic items and starts seeing two solid bounded groups of 10. It creates this concrete physical foundation that is absolutely crucial before we can even think about tackling larger, more abstract numbers.
Now that we have that concrete foundation, it's time for scaling up using something called the Ginladi tool.
So, once that core concept of 10 is locked in through physical objects, like those boxes of oranges, this pedagogical journey introduces the specific representative tool to help scale those numbers up. It's called the Ginladi. The crucial thing here is that learners use this counting string to physically place number cards in sequence. This allows them to visually grasp patterns and even practice counting backward with total confidence. The material actually instructs learners to pick up number cards from 1 to 50 and physically clip them onto the Ginladi at the exact right place. It acts as a physical, manipulable number line. When a learner actively clips a number, say 41 or 49, onto that string, they're literally bridging the cognitive gap between the physical oranges we just looked at and the abstract concept of pure written numbers. The text even encourages using this string to count backward, which builds immense confidence and mental flexibility.
And just as things get going, we encounter Farha's matchbox mystery.
As we hit the halfway point to 100, the text does something so incredibly smart. It injects a mystery to keep the learner totally engaged. The chapter poses this fascinating scenario where a character named Farha claims she packed more than 50 amazing things into a single tiny matchbox. Obviously, her friends are wondering, what could these things possibly be? And they get a huge surprise when she finally opens it. I love this because it completely interrupts that linear, predictable counting process with a highly engaging real-world puzzle that grabs the learner's attention right when it might have started to wander.
Now, what's really fascinating about this is how it forces the learner to suddenly think about scale, volume, and the physical reality of the number 50. Think about it. Up until now, 50 was just a place on a string or 5 boxes of oranges. But here, the text challenges the learner to actually collect items and see exactly how many a matchbox can hold. Can you fit 50 pebbles in there? How about 50 grains of sand? Maybe 50 mustard seeds? This kinesthetic challenge ensures the number 50 isn't just rotely memorized. Its physical weight, its spatial requirement, its volume, they're all deeply internalized by the learner. They literally have to hold the concept of 50 right there in the palm of their hand.
So, with 50 mastered, we are officially reaching for 100. Having locked down the concept of 50, the chapter really accelerates. Rather than just counting objects one by one forever, which would be exhausting, the text chunks the rest of the journey into manageable milestones to keep the pace brisk and intuitive. We see this really structured acceleration. The source moves from count and write the numbers from 51 to 60 to a much larger leap of 61 to 80, and finally, the sprint from 81 to 100. Because the foundational logic of tens and the physical scaling of the Ginladi were so solidly established early on, the learner doesn't actually need baby steps anymore. Their cognitive load is way down because they understand the pattern. They can just rapidly scale their understanding across these larger milestones, all the way up to that magical number 100.
But learning doesn't stop there. Next up, math through play.
Okay, so we've reached 100, but the chapter doesn't just stop at rote memorization and call it a day. It immediately applies this brand new knowledge through dynamic play. This grid represents the ultimate abstract realization of numbers 1 to 100, beautifully transformed into a highly visual and super familiar slide and ladder game. The source material provides this visual grid containing slides and ladders and then actually asks learners to fill in the missing numbers from 1 to 100. Doing this requires the learner to navigate a two-dimensional space, really understanding number sequences both horizontally and vertically. It's a fantastic way to solidify the sequential order while framing the whole review process as a highly rewarding game rather than, a stressful test.
And it goes a step further by suggesting physical outdoor modifications, literally turning abstract mathematical grids into a kinesthetic, full-body learning experience. The text encourages drawing the grid outdoors with chalk and using actual sticks and ropes for the slides and ladders. But here is the truly brilliant part. It suggests modifying the instructions with cognitive challenges. Things like jump to a number where the digits are exchanged, for example, jumping from 12 to 21, or skip one number on your right and jump. This transforms simple counting into complex spatial and numerical reasoning. And the whole time, the learner is physically moving, engaging their gross motor skills. Educational research tells us this heavily aids memory and retention. It is learning by doing in the absolute purest sense.
Finally, we bring it all together with art, culture, and math.
The chapter concludes with this beautiful, really unexpected integration of math, art, and traditional culture. By ending with a question about traditional Warli art from India, it leaves us pondering how the math we just learned is secretly hidden everywhere. The text asks learners to guess how many lines are used to draw the leaves, which implicitly applies their newly minted counting skills to cultural appreciation. It beautifully demonstrates that math isn't just, numbers on a page. It's literally the structural language of human expression. After seeing how carefully this entire journey is crafted, from playful animals to boxes of oranges to physical strings to games and finally to cultural art, it really makes you wonder, what other invisible structures in our world might just be waiting for us to count them? Thanks so much for joining me on this explainer. Keep looking for those numbers hidden in your world.